a sheet of paper, however you would like to. And we're going to be kind of cutesy. If you don't have a sheet of paper, you can sit and just watch. This is recorded, so you'll be able to get the gist of it. So, let's have a little bit of fun. It's not as fun as the orange story, I'm sorry. I brought a ruler. It even says stirrup on the back. So, let's talk. Unfortunately, we don't have the ice cream to go into the ice cream cone, but we have an ice cream cone here. So, this ice cream cone has a few characteristics that we could figure out. Now, it's kind of hard to, maybe we could think we're standing it upright to measure the actual height, but it might be tough to measure the actual height of this ice cream cone because I don't know if I can, it's kind of weird indentations. So the actual height, I don't know if we can find right off the bat accurately. But I feel pretty good about the slant height of this object. And the slant height of this object is right down the edge of this. And this appears to have a slant height of 12 centimeters. That seem okay? Now the radius might be hard to find because I don't know where the exact middle of this ice cream cone would be. But I could probably figure out the diameter. What do you think? And being I measured my slant height in centimeters, I think maybe I should measure my diameter the best I can in centimeters. So it appears that it is 4.8 centimeters for a diameter. So if that's 4.8, what would the radius have to be? 2.4. Seem okay so far? So I think with that kind of information, we could find a few things. We could find the surface area. And let's ask you all this. What kind of surface area does an ice cream cone really have, and why? A lateral. Why? Yeah, it needs a place to put the ice cream, right? So we're missing. So we only have a lateral surface area. So the lateral, which is just the cone itself. Anyone remember what this would be? Of a cone?
Radius times the
Close.
radius times
Who? Pi R L. Well, pi is pi. R 2.4. L. Oh, we found that. Cool. And if we were to multiply that out, keeping pi as pi, we are going to get an answer in square what? Square centimeters? Because we've measured in centimeters. So help me out. What is 2.4 times 12? So it's 28.8 pi square centimeters. So if we were at that fancy ice cream place, you still with me? And they said, did you want your cone dunked in chocolate? And they drip it in this way, and they go, and it doesn't fill on the inside because you had pushed it down, and the air didn't allow it to trap in. The whole outside of this ice cream cone, we would have 28.8 pi square centimeters worth of chocolate on the exterior of this cone. Okay. So now we want to know how would this relate to the volume of the cone itself. We're not going to heap over the top. How do I find the volume of the ice cream cone? Any ideas? If it was a cylinder, what would it be? Let me ask, if it was a cylinder, what would it be?
radius squared squared times height.
So if it was a true cylinder, this would be pi r squared height. Okay? Now, yeah.
Okay, wait. So for the surface area, we actually the pi r L is actually the lateral area, right?
Yes.
Okay.
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 Because we didn't include the top. There was no circle.
So then, what's the surface area of the?
Then it would be pi r squared plus pi r L. So pi r L is the cone itself. Pi r squared plus pi r L would mean you have a top on the cone. All right. So this is how you would find the area of or the volume of a cylinder if you had the exact same radius or diameter and the exact same height. So if this was the same height as this, it's going to work. Quick question. Math has all kinds of things that are wonderful. If I had taken this ice cream cone and I made it a cylinder, so the top and the bottom were the same size circle, how many of these ice cream cones do you feel would fit as far as a cylinder would go?
2/3.
Real close. So how many of these ice cream cones do you think that I could put in here from the top, from the bottom? 3. So that means that the volume of this, the volume of a cone is 1/3 the area of the base times the height. Well, what's the area of the base got to be as far as this goes? Don't be the kid going, but it's a point. No, what's the base? The base is on top right now, isn't it? So the base is going to be pi r squared times the height.
Is this going to be on the decimal?
I don't know. It's pretty simple. R is what? 2.4? Height is?
No.
Do I have the height yet?
No.
No. Let's pull out that triangle. I have a radius here of 2.4. I have my slant height of 12. So I don't know what this is. So Pythagorean theorem, you got to help me out. I don't have the math skills. X squared plus 2.4 squared equals 12 squared.
It's 5.76.
Okay, so x squared plus 5.76.
44.
144, help me out here.
Minus 5.7. It's
138.24. Square root
is 11.75.
11.75. 11.75 happens to be the height. You okay? All right, 11.75. All right, let's do the math. Let's go 2.4 times 11.75. 2.4 times 11.75.
28.2.
Divide that by 3.
Okay. 9.4.
Oh, I didn't square pi, did I? Pi r squared, thank you. Oh, wait, let's back up.
2.4
Squared is 5.76, right?
times 11.75 divided by 2.
3.
No.
22.56 cubic what? Centimeters. And it's cubic centimeters, not square centimeters, because it's a volume.
That's a lot of math.
It's nothing impossible. Pythagorean theorem.
That's not what all that is.
Oh, sorry. 1/3. Yeah.
So the whole thing with this cylinder is just to explain why it's 1/3 base times height for a cone.
So if I took a cylinder like this, but then let's say I also had a cone where this was the same and I had the same height, I could stick 3 cones. The volume of those 3 cones would fit into this one cylinder.
So
That's why it's 1/3.
Okay.
So if I told you, hey, you have a cone that's this area, what would the volume of the cylinder with the same dimensions be? You just have to multiply that by 3. Johnny.
Wouldn't it be 22.565?
Oh, I forgot pi? Oh, thanks, man. Yes. Thank you. Yep, there's pi in there. Cool. Look at that. That works. All right. What should we find next? Yes. Yeah, volume equation. So volume is area of the base. Area of the base is pi r squared. So area of the base is pi r squared, so pi is already there. So I don't have to put height in the bottom equation, it's already built in with the area of the base.
Oh, okay.
Okay? Alright. Chocolate. Swiss milk chocolate with honey and almond nougat.
We should eat that. It's so good.
What is nougat?
It's like
this little.
It's a nugget.
Stuff,
It's an
right?
almond nugget.
it's like a
It's
Turkish
like-
thing.
Have you ever had
Nougat?
Chicken
bar?
nougat? Yeah,
It's so good.
I've heard nougat before, but I don't know what nougat is.
We could try it. No, no.
It's
Yeah, yeah, we
bar.
should all try it.
I mean, because like we could use the box as like the demonstration, but like the stuff inside, we can like utilize that.
I would say it does feel like there's something in. Yeah, I don't want to trust it.
Should be using it as a
It's science.
reference.
People would probably be upset. I mean, there's not enough for everybody, so everyone would get like a lick.
Or we could have
Or
a competition.
Oh yeah. Or we could get a
And win it.
take-home test tomorrow.
You're right.
Yeah.
Alright.
Competition.
so let's think about our candy. That's our candy thing, right? So what are a few things we should know? So I know that the surface area
It's big number.
is going to be the triangle times 2 because I have a top and a bottom, right? Plus how many rectangles?
3.
Yeah, 3 rectangles.
That's
Is that okay?
Yeah.
A few things about yes.
Are you not know like definitions of prisms versus pyramids or just like the
Bases. All right. What kind of triangles does that kind of look like?
equilateral? Is our test gonna have volume?
Probably not, but I was just adding this in there. What does it got? What?
Equilateral.
Looks like an equilateral triangle. So it does appear that this is an equilateral triangle, so all 3 sides are equal. So the equation for an equilateral triangle was what? Root 3 over 4 times the side squared, right? Okay. Centimeter seems good to measure this in. This would be 3.5 centimeters. 3.5 centimeters, so all the way around is 3.5. So let's find the area of the triangle. Root 3 over 4,
Shut up.
3.5 squared. Okay, 3.5 squared's how much?
A big old one.
Okay, good. Bigger than 9,
Yeah, definitely bigger.
smaller
than
than 16.
It's
12.25. 12.25 divided by 4 is
like 3 something.
3.06.
See, wasn't wrong.
3.0625 root 3. Okay? How many of those types of triangles do I have?
2.
And that's square centimeters. So let's multiply 3.0625 times 2. What'd you get? 6.125 plus, 3 rectangles. Okay, so the dimensions of my rectangles, I know that this side will be 3.5.
What about the root 3?
Oh, I forgot it again. Root 3. Root 3. Thank you. All right. Sorry, they give me chocolate and act like
You know, if we cut each piece in half, there'll be 24 pieces, and then we can all just have one.
Exactly.
What about
Can
6
we
period?
vote on that? No, but then you just don't show them the
period's
video,
not gonna
or
know.
and you'd be like, here's an
I got
open
it on
box.
video though.
They're not gonna see it.
Yeah, but you're
it's
gonna
nothing
have to
after
watch
this.
it.
We don't know after.
Can we like vote on this?
There was the video for the other day.
All right, I got 20.9 centimeters is the length.
Alright, cool.
So that's 20.9 centimeters. So, do I have enough information to find the area of one of the triangles? Yeah. So 20.9 times 3.5 is how much? 20.9 times 3.5 is how much?
Hold up.
It's like 60 something big.
Good.
What'd you say?
73.15. And, okay, so we have enough math to do this. So I have 6.125 root 3 plus, what is 3 times 73.15?
Gosh, okay, chill.
It's 219.4.
219 what?
219.436.
0.45?
Cool.
Square? Square what? So, the surface area of the top, the bottom, and the three rectangles comes out to 6.125 root 3 plus 219.45 square centimeters.
Wait.
Could I find the volume of this? Volume is just base times height. What was my area of my base?
Good stuff.
My height would be 20.9. Good. All right, what is 3.0625 times 20.9?
3.0625 times 20.9 is 64.0006. 2006.
What?
2
Centimeters cubed.
Cubic centimeters. Good.
What about the
Is the rest of the number?
Oh, and the root 3, thank you. God, love you guys. Yeah, 64.006 root 3 cubic centimeters is my volume. I think we got time to do one more.
From the take-home
Hopefully
quiz?
y'all know what this is.
Yeah.
The take home.
From the take-home quiz.
Nope.
Right?
Yeah, it's from the take-home
Can we
quiz.
please just have like
Please.
one take-home quiz?
Oh, yeah, the final.
I would enjoy that.
Final, do at the end of the summer. You'd be all ticked off at me going, man, he gave us the whole summer to worry about this, and I'm just going to really wait until the Sunday before.
I lost my final.
All right. I lost it. TP.
You mean a really tall shot?
Yeah, I actually did. How much you I didn't wait sight.
Sawyer, I can hit the first try.
All right. Ooh. All right, let's think about the surface area of this bad boy. Okay. So I have a top and a bottom times 2. Yes? All right? Yep. So let's figure out. So the entire diameter all the way across. Oh man, I just forgot. If my memory was good, I'd be so much better. So our diameter is 11.5. And then the diameter of the is 4.
Yeah.
And then the diameter of this centimeter. All right? The height of this is 10.5. All right. So I want to find the total surface area. So circle on top, circle on bottom. Yes? The surface all the way around here, and the surface where?
Inside.
Inside. In the hole, right?
I see you.
I see you. All right.
Find the diameter of the inner circle.
So let's find, the diameter of the inner circle is 4. The diameter of the big circle is 11.5. So I think we can find the area of the circle. Area of the circle is pi r squared, right? So let's find each of those first. So area of the big is 11.5 squared pi. And if you have a calculator, figure out 11.5 squared for me, please. Plus, or wait, minus 4 squared.
It's 132.25.
Oh, wait. What did I do wrong?
You didn't.
I have the diameter, not the radius. Okay, so I need to cut that in half. So that's got to be 5.75 squared pi
33.262.
minus 2 squared.
Yeah.
What is this? What?
33.0625. See, Don,
Sawyer keeps copying my answers.
get good.
minus 4 pi. So that's going to be 29.0625 pi. And I'll multiply that times 2 because I have a what and a what? Base, 2 different bases, right? So 29.065 times 2.
78.13. Oh, it should.
58.125.
58.
9.125. No, it's 58.
It's 68.13.
What?
29.065
Times 2.
Oh, times 2.
58.13.
Yeah, 58.13.
No, you said like 78.
Sawyer, see the freaking right
1/3
answer.
pi. All right, so that's my area of my top and my bottom. Not this bottom. You know what toilet paper side.
Oh my god.
And then you have to do the circumference of.
For that, we should be
All
able to
right,
take
so
out
the
this-
circumference. All right, so the circumference is 2 pi r. So the circumference of the big is going to be 5.2 times 5.75 pi,
11.5
11.5 pi, times the height, 10.5. Help me out there.
120.75.
120.75
Good job, Doug.
pi.
Right.
Square centimeters.
That's the.
So that's the lateral area of the outside. The lateral area of the inside is going to be
10.5 times 4.
c equals 2 times pi
Times 2.
times 2. So that's 4 pi times what?
Wait.
10.5.
The circumference of a little.
Are you finding?
Circumference of a little circle, yeah.
Oh.
What is 4? 4 times 10.5. Almost done.
42.
4, yeah.
40 what?
Wait.
42.
42 exactly?
Yeah.
42 pi. All right. So, if we wanted to figure out the entire surface area, including the inside, I have this plus this plus this.
Freaking heck.
So I know pi is part of our answer, and it's in square centimeters. So what's 58.3 plus 120.75 plus 42?
220.88.
220.88 pi square units. All right, so boys and girls, we have a review worksheet 11.1 through 11.4. Okay, so let's make this, we'll make this one due Monday. I mean, you should work through it, right? And then I will then collect 11.5 is due on Friday. Okay? And the take-home quiz that you're all hoping for. Just don't know. Just don't know.
We do have to take a